Welcome to our SEMM 1213 Dynamic Project, the Rube Goldberg Machine Challenge 2025. Over the past semester, our team of 8 students designed and built a fully mechanic machine to demonstrate the principle of motion, energy, and force, all just to launch a simple paper airplane. This project wasn't just about engineering. It was a journey of creativity, problem solving, and teamwork. So without further ado, let's dive into how we turn theory into a chain reactions of ingenuity. A Rube Goldberg machine is more than just a whimsical contraption. It's a lesson in physics. Our machines relies on the domino effects, where one event triggers the next in a cascade of motion. At its core, this project applied Newton's second law, force equals to mass times acceleration. But motion isn't always linear. For example, when a domino falls, its center of mass follows a straight curve. This is curvilinear motion. Meanwhile, the collisions between domino involve relative motion, where the velocity of one domino is observed from the perspective of another. This principle guided every step in our design. Problem statement. The challenge was clear. Build a machine that launches a paper airplane within a configured 150 cm by 150 cm space, using only mechanical components, and complete the sequence in 10 to 20 seconds. No chemical, no shortcut, just pure physics. We had to incorporate concepts like displacement, force, energy conservation, and so on. Objective. Beyond the technical goals, this project had a deeper objective. First, to understand physics beyond textbook, like how torques affect a pendulum swings. Second, to foster creativity. One team, for example, uses a Ferris wheel to redirect dominoes, which is a solution born from trial and error. Third, to cultivate problem solving. When our domino chain keeps stalling, we realized spacing was the issue and recalibrate each block. Finally, Rgmc taught us perseverance. Failure isn't an endpoint. It was a step forwards, refining our machines until every mechanism works in harmony. This is the overall setup of our Rube Goldberg machine. Now, I will explain it part by part. The machine starts by pulling back a plunger, which is a spring-loaded rod, and releasing it to launch a marble onto a ramp. The marble rolls down the height ramp using gravity and falls into the paper cup positioned at the bottom center. This paper cup is connected by a wire to the right side of the seesaw at the top right of the board. So when the marbles land in the cup, its weight pulls the right side of the seesaw downwards, causing it to tilt. As the seesaw tilts, another marble placed on the left side rolls off into a sliding tube. The marble slides down, get projected into the air, and lands in the catching system. From here, the marble hits a series of dominoes, starting a chain reaction that continues through the rest of the machine. This part of Rube Goldberg machines uses Newton's cradle concept to transfer energy through collisions. When one ping pong ball is released, its gravitational potential energy turns into kinetic energy as it swings. Upon impact, the energy of momentum are transferred through the line of balls, causing the last ball to swing outwards. The chain reactions continue as the domino besides the roller falls, pushing the rollers to roll down and collide with another dominoes, continuing in sequence. This process demonstrates conservation of momentum and energy. True, some energy is lost because ping pong balls are not perfectly elastic. Each part works together to keep the chain reaction going. This part uses a domino-triggered rotating arm system combined with a pulley to continue the chain reaction. The domino hits the first rotating arm, which is located at the bottom right, cause it to rotate and transfer energy to the next domino on the first layer. The same process repeats on the second and third layer, causing the last domino to fall into a paper cup. The cup is part of the pulley. As it falls, it pulls up the basket on the other side. The basket is connected to a Ferris wheel, which rotates. A chopstick attached to the Ferris wheel hits another domino, continuing the chain. Finally, the sequence causes a hammer to fall and release a clip, launching the paper airplane.
Maybe the distance between the last ball and the first domino.
It's not necessarily when
I would say, it's some. I would say maybe when the ball hits, maybe it goes some for this one, and also tell my maybe it's too much. So maybe we didn't use the but after we tried it, we found that the bubble is not effective. Maybe ensure that we can pockets. It's better to use it's better for the students to measure the amount of size and so this is more my idea before this, maybe we could put some sand or something heavy. Why? Because the rule says we cannot use something like water, sand, because we want to. I asked my teammate to brainstorm 3-4 times before we started. One team thinks especially on this one, like the decoration thing. I never saw the decoration like this.
The overall competition was successful and provided a valuable experience. The pulley system and the level system worked as intended, successfully knocked down the domino as our expectation. As for challenges, the pendulum didn't work as expected due to environmental effect. The ping pong ball's moving trajectory were affected by the wind from the air conditioner. For improvement, we should conduct through testing and fine-tuning of mechanical connections before the events to ensure our machines work perfectly. Besides, we should add more decorations and visual elements to make our project more engaging and appealing to the audience and judges. Last but not least, we should ensure each step of the mechanism is demonstrated perfectly. This project was just more than a grade. It was a testament to what teamwork and applied science can achieve. We learned that the physics isn't just equation. It is the reason a domino can topple a hammer, or a spring can launch a dream. The failures, like misaligned domino or mistimed release, taught us resilience. The successes, like first flawless run, were unforgettable. Rgmc remind us that engineering is both analytical and imaginative, and that the best solution came from collaboration. As our paper airplane scored, so did our appreciations for the machines behind every miracles.